from your afternoon break to the Python 2 Memorial Concert Hall. Our next presenter is Sanjay Siddhanti, who will be talking about testing code that uses S3. He'll be in the venue list chat during the presentation for conversation and any questions you may have. Take it away.
Hi, I'm Sanjay Siddhanti, and today I'll talk about 3 ways to test your Python code that uses Amazon S3. In this talk, I'm going to start by motivating why someone should want to test code that uses S3. Then I'll introduce a really simple create, read, update, delete app that's backed by S3. We will go through the process of writing tests for this application using 3 different libraries. And at the end of the talk, I will compare and contrast all of the libraries and discuss which tool is best for whatever job you're trying to accomplish. But first, I want to talk about testing external systems. Sometimes people are testing code under time pressure. They need to ship the feature and move on. And when this happens, a really common thing that I see is to skip all the code that interacts with external systems, whether that be S3 or a web server or a database. My hypothesis about this is that testing code that interacts with external systems is unfamiliar and intimidating to a lot of people. Everybody knows how to write a unit test for a pure function, but not everyone knows how to test S3, for example. A lot of people also think that these tests are not necessary. People say that by doing these, you're just testing the API. But I don't think this is fair. You're actually testing any assumptions your code makes. You're testing business logic that goes along with using the API. And honestly, testing the API can be okay sometimes because, as I'll show later in the talk, some of these services have really complicated APIs and it's very easy to introduce bugs. And that segues me into the third point, which is that I believe that these tests, even just a few of them, can go a long way towards catching bugs in critical business logic. Just to think about your own code, everyone should take a minute and think. Do you have a system that uses S3 for some critical piece of logic, whether it be static web hosting, or storing files, or using it in an ETL process? In this talk, I hope to not only convince you that testing S3 is important, but I also hope to give you some new tools so you know how to get started next time you have this problem. Let's get started by introducing a simple create, read, update, delete app for cooking recipes that's backed by S3. This app is only about 20 lines of code if you don't count imports and doc strings. The application uses an S3 bucket called recipes. There's a class, a Python class called recipe. The class has a name and instructions, both of which are strings. It has a method called getByName. This allows you to look up a recipe in the S3 bucket based on its unique name. It also has a method to update the instructions for a recipe. You'd use this when you have an existing recipe and you want to put in new instructions for it. It works by getting the existing recipe by name, updating the instructions, and that's it. There's a delete method that allows you to get rid of recipes that you no longer want to store in S3. There's a helper method that helps serialize the data to JSON, which is how we'll write it to the file in S3. And finally, there's a method called save that actually persists the data to S3. So this is really short and really simple. So let's get into writing tests for it. We're going to go through 3 options. And the first one I want to talk about is called botocore stubs. You might be thinking, okay, this is built into botocore. So this is the recommended way to do it. But actually, the subtitle for this section is called How Not to Test S3. I want to show you how painful this process is of using botocore stubs so that you'll appreciate the next two solutions even more. Botocore stubs work by letting you create a stub S3 client. So I'll give a bit of background here. First, we're creating a PyTest fixture. Within that fixture, we're making a botocore stub. We stub out the S3 client, and then we yield that. What happens within a PyTest fixture is that when we yield, the test has access to this stubbed out S3 client, and it can use it, as shown below. The S3 stub works by allowing you to basically add on stubbed out responses to it and then pop them off one by one. So let's go through an example. Let's say we want to write a really simple test to create a recipe and then get the same recipe. Just create it and then fetch it. To do this with botocore stubs, we have to stub out both of the S3 requests that would be involved there. The first one is a put object request when we create the recipe, and the second one is a get object request when we want to fetch it. So here's an example of how we would stub out the put object response. We have to put in a bunch of these fields that, honestly, I didn't even really look at before writing these tests, like the request ID, the number of retry attempts, and so on. And actually, for brevity, I omitted lots of fields from this stub, but there's many more that actually come back in the request. Once we've created this stubbed out response, we can add it to the fake S3 client we're using, as shown in this line. The next part is that we need to stub out what the get request will give us back. This one's even harder because the get object API will return a streaming body with the content. So I have to create that myself manually. So here what I'm doing is I know what the contents of the file are going to be. And so I'm using that to manually create my own streaming body that looks pretty similar to what I would expect the S3 response to contain. Then I can stub out the full get object response. Again, it has a bunch of stuff that we probably don't care too much about, like request ID, last modified, content length, but most importantly, it has this streaming body in it. And we can add that to the stubber. Now that we've stubbed out both of the responses that we expect to need, we can activate the stubber, which means we can start actually making requests that use S3. And every time we do that, a response will be popped off of the stub in a first in, first out manner. So first, we're going to make the put object request. So we create a Python object here for the recipe, and then we save it, which we'll call put object to put that data in S3. And what's happening under the hood here is that our mocked out put object response is being returned instead of actually hitting S3. And then we can fetch the object the same way using get by name. And what's happening under the hood here is that our second stubbed out response is being returned. So you'll see that botocore stubs are functional. They did allow us to write a working test here, and that's worth something. But I really do not like to work with them. And there's a few reasons for that. Creating stubs is very time consuming. It requires a lot of prep. One way to speed it up is to run the real code interactively, for example, with a debugger or in an IPython shell, and copy the response out. But even that doesn't work because some things need to be replaced, like the streaming body that I showed above. Another issue is that these stubs are fragile and fake. Responses are returned first in, first out. So if you call the S3 APIs in a different order than you added the responses to the stubber, it will throw an error. It has no flexibility. A third problem is that to make the stubs look even somewhat realistic, you have to mock all sorts of fields that your code doesn't care about. And you end up bloating your tests with fake responses. We can actually see that here in our test. The actual test itself was about 5 lines of code, but we added tons and tons of code just to get the stubs in place. And finally, one thing I don't like is that botocore stubs leak implementation details from the module that's being tested. So, for example, if a module switched its internal implementation from using the listObjects API to listObjects v2 API, this test would fail because it depends on a specific API being called. This creates an unnecessary dependency on the private API of the module instead of just testing the functionality or the public API, which is the better thing to do. So now that we've seen some problems with botocore stubs, let's move on to the second solution, which is called Moto. Moto is a Python library that makes it really easy to mock out AWS services in tests. Here, we're creating a similar Python fixture or PyTest fixture to what I showed you just before. But what we're doing is we're just calling a function from Moto called mock S3. Within this context manager, when we've called this function, all requests to S3 will be directed at Moto's virtual AWS account. So we basically have a clean slate to start with. That means that we can create a client, and this Boto3 client is going to point at Moto's AWS account. And we need to create our initial bucket that we'll be using. Once we've done this, testing our code is super simple. So let's go back to that same test. We want to create a recipe and then fetch it. So here we create the recipe and persist it to S3 on the first line. And then after that, we fetch the recipe by its name, and we make some assertions about the data that's in it. This is really easy. We didn't have to do any mocks or any stubs besides just setting up this one mock S3 function and calling it. And it didn't really require any changes to our original code. Now let's go ahead and test the rest of the application too. So another useful test to do is to make sure that we are not able to fetch recipes that don't actually exist. So let's try to fetch a recipe that doesn't exist, like sandwich. And here we'll tell PyTest that we expect this line of code to raise the no such key exception. And if it doesn't, then the test should fail. We also want to be able to test updating a recipe, and there's specific semantics around that our application chooses to use. So let's say we were making nachos, and we had original instructions, and then we decided we wanted to add more detail to them. On this line over here, we create the recipe and we persist it to S3. Then we call update, which will create a new Python object that has the new instructions on it. But the key thing is that we haven't called save yet. The semantics of this particular application are that things should not be persisted to S3 until you call save. So let's check this. When we fetch the recipe from S3, even though we've already called update, we still get the old instructions back because we haven't called save. Then when we go ahead and call save, and we fetch the data again from S3, now we see that the new instructions are there in that file. So this is useful to help us test the semantics of our application. We also want to test that we can delete a recipe if we don't want it anymore. So here on the first line of this test, I'm creating a recipe, putting it in S3. Then we're calling the listObjects v2 API. We're seeing that we see one file in our S3 bucket, and the file name is nachos, as we expect. Then we call delete on that file, or delete on that recipe, and we list the objects from the S3 bucket again, and this time we don't see any objects in the bucket. So we know that the delete worked. So With these few tests, we just got to basically 100% test coverage for our small little application. And overall, I think Moto does a really excellent job of implementing the S3 API. Moto is really easy to use. It feels just like the real S3, and it doesn't require any code changes. So I'm very happy with this solution. And I want to present one more option called LocalStack. LocalStack is a library that allows you to bring up an entire AWS cloud stack locally. Unlike Moto, LocalStack is not something that you can just pip install and import into your application and expect to use it immediately. You actually need to bring up a local server first. The easiest way to do this is with Docker. So below, I've posted my docker compose.yaml file that I used to bring up LocalStack and then run PyTest against it. And I'll show you how to use it. The thing I want to focus on most is this initial fixture right here. You'll see this fixture is very similar to the other ones we wrote, but with one key difference. Instead of calling mock S3, here we're actually using the boto3 client, but when we create it, we're pointing it at a specific endpoint. So we're pointing it at the endpoint where we have LocalStack running. What this will do is what we basically have now is an S3 client that's pointing to our virtual LocalStack AWS account. So again, we need to create the initial S3 bucket. And then we use mock.patch here to patch the get S3 function, which returns a boto3 client for S3. And we have it return our LocalStack boto3 client instead. The reason I wanted to focus on this fixture is it's actually the only thing we have to do differently between LocalStack tests and Moto tests. With this fixture in place, we can run the same exact tests that we used for Moto. I've repeated them below for completeness, but I'm not going to go over them again because we didn't modify them. And I think this is a really powerful property, is that when two libraries do a good job of implementing the API, one way you can tell that is that you can actually swap them out and you don't see any behavior changes. So I'll just scroll through these tests here to show you that they're the same. And all of this code is also available on my GitHub. So in summary, LocalStack, in addition to Moto, also does a really great job of implementing the S3 API. So that leaves us with two really good solutions. So I want to pause for a moment and talk about testing external systems. At the beginning of this talk, we said that testing external systems is really hard. People are intimidated by it or unfamiliar with it. And I hope you've seen here that it doesn't have to be hard. My advice is to look for libraries that look and feel like the service you're trying to test. If you find yourself writing time-consuming mocks or doing things that feel brittle or fragile, then there might be a better solution out there. And in our case, both Moto and LocalStack meet the bar of technologies that we want to use. They both implement the S3 API. They both feel like the real S3, and neither of them required any code changes to our application. And I want you to know that this isn't just about theory, and it's not about writing tests for fun. These types of tests have actually helped me catch real bugs in my career. And here I'll name a few of them. First, I misunderstood how S3 versions were created when I first started working with version files in S3. This led me to make an assumption that was incorrect. I assumed that if I had the same file contents, I could copy those objects to another bucket and the versions would be the same. I wrote a test and realized this was wrong. I also didn't understand the proper way to permanently delete versioned objects. Again, both of these examples, the top two examples, could be considered testing the API. But really, in this case, it was testing my code programmed by me, and I was the one who made incorrect assumptions about the API. And that's why these tests were still valuable. Another bug I found was that I work on ETL processes. And one time I found that I wasn't moving files around to the correct destination. And testing helped me catch that before anything went out to production. So I want to conclude by talking about which library you should use if you picked up a new project today. Both Moto and LocalStack are useful in that they can actually both be used to test code in multiple languages. So Moto is a pure Python library, but if you wanted to use it to test code in other languages, you could spin up a local server. It supports that mode, similar to how we use LocalStack. They're also useful because they both implement mocks for many other AWS services in addition to S3. For example, they implement mocks for EC2, RDS, Lambda, and at least a dozen other services. The benefit of this is that by investing in one of these libraries, you get more than just testing S3. You get to learn, or you get a library that will help you test all of your other AWS resources. Now for the differences between the two of them. So Moto is pure Python, and it requires no extra build step if you're using a Python test suite. After all, we're here at a Python conference right now. I would say Moto is super easy. You just pip install it and import it into your code, and you don't have to set up any other infrastructure. On the other hand, LocalStack's architecture and internal implementation details are probably more realistic to what you would expect a cloud service to be implemented like. For most people, this won't matter. But if you wanted to do unit tests that test like large-scale reads and writes, for example, then LocalStack's architecture might be better suited for that. In my opinion, you really can't go wrong with either solution. For me personally, if I'm using a Python project, I use Moto because it doesn't require an extra build step and it does the job perfectly well. But if I'm already using a different language, and either way, I would need to spin up a server in Docker, then I go ahead and use LocalStack because it seems like it might be a little bit more realistic or more powerful. So thank you so much for watching my talk. All of my code is available on my GitHub, and you can also reach out to me on Twitter with any feedback or questions, and I'd be very happy to hear from you.